Good afternoon, and thank you for joining us for this demonstration session today titled Technician Trends Visualized, an interactive data tool. Really exciting to share with you this new tool that's been developed under our research project, a targeted research project. And I'll tell you a little bit about the overall research project to give some context for this data tool, and then let my colleagues share with you a little bit more about the tool itself and how it can be used. So as background, the project that we're talking about is called the Hidden Innovation Infrastructure, Understanding the Economic Development Role of Technician Education in the Changing Future of Work. And so the big idea here is really to understand how ATE and related technician education programs at community colleges are related to economic development and how they help support economic development in their local communities through the technician education in terms of skill development of students, as well as the broader connections to the regional economy through business support and development and regional engagement that the colleges engage in. And looking at these various factors, we're interested in seeing how they can be connected to sort of economic development outcomes that are related to technician education, including generally a more skilled technician workforce, ecosystem and industry and innovation ecosystem that is more productive and innovative, and to see those productivity and innovation gains played out in the workplace, as well as looking at trying to tease out some of the broader ripple effects in the regional economic environment, and knowing that these are very tricky connections to make, because technician education is one of many factors that obviously flow into economic development. But we're trying to look at some of the policies and practices from technician education that are important in supporting economic development. So that's the big idea with the project. And I'll share with you some of the other activities that the project is engaged in. It's a large project, just finishing up the first year of 4. And the project includes 2 components. One is a national analysis of ATE and community college technician education. As part of that, we're reviewing past and current ATE grantees in terms of some of the activities that they're doing that are related to economic development. And we're also doing a quantitative analysis of existing data to look at trends and impacts on economic development. And the tool that we're going to talk with you about today is one part of that quantitative analysis, looking at trends in technician production across the country. And we're really excited to have this sort of interactive data tool that Bill will talk more about in a moment. The second thing that this project will cover is regional case studies, taking a deep dive into manufacturing programs within particular regions and firms, and that will include in-depth surveys and in-depth interviews and employer surveys. And that's something to come in future years. We'll look forward to sharing more with that with everybody on that. So those are our activities, and the project team includes a wonderful a group of characters, including myself, Michelle Van Noy. I'm from the Education and Employment Research Center at Rutgers. Another colleague, Renee Edwards, who's not on the session today, but is taking a lead role. Marilyn Barger, who is our partner, who's going to talk more in a moment, and likewise Bill Mabe, who's been leading the administrative data analysis, and Andrew Weaver from the University of Illinois, who's not on this presentation. But we're really excited to have this great team, as well as other partners who are helping to inform and engage this work. And we look forward to sharing more about the broader project, but really excited to hand the presentation over now to Bill to talk more about this wonderful interactive tool that we have that we hope will be of use to many people in the ATE community. And then Marilyn will talk more about sort of some of its potential uses. So thank you.
Hi, everybody. My name's Bill, as Michelle said, and I'm really excited to talk to you today about a lot of work that's gone in to produce this tool that I think could be helpful for community colleges in terms of getting an understanding of programs that they might offer, and kind of the training that's taken place in various technician academic fields, as well as some insight into the occupational demand for different types of technician programs. So basically this is a specific application looking at technician production. So kind of looking at the supply side of the technician equation with a little bit of information as well, kind of on the demand side, looking at occupational employment. So we're the app displays the technician graduates per year, and in order to allow people to kind of see what has been the evolution of the number of graduates completing technician programs over time, and we have data going back since 1995. We're presenting the data both at the national level and at the state level to see national trends as well as state level trends, hoping that with the data at the state level, it might be a little more useful for local colleges to kind of see what's happening in their state or what has happened in their states. And the hope is that it's easy to use. There are some instructions on the tool, as you'll see, and kind of a user guide at the end as the final tab that hopefully can kind of help guide people through using it so that it's not too challenging to navigate. And so it is a web application, so I'll be demonstrating that shortly. I think one key question that people may have is, okay, who's included in this data tool? And we're looking, and I think there's a couple of kind of ways to understand what data elements are in this. Who are the students? Like, which students are included? We're looking only at graduates, so we're not looking at students who are enrolled. We're looking at graduates only, and we're looking at anyone who has earned a degree that's up to the bachelor's degree level, actually. So this below is actually incorrect. So we've actually added it so they now include bachelor's level earners as well. So graduates, bachelor's level and below, and which programs are included. So the programs that are included are technician programs specifically. And I'll kind of define what that means on the next slide and give you some rationale for why we decided to define it that way. And then we're using the 4-digit classification of instructional program codes. So that's the National Center for Education Statistics method for classifying academic programs to divide up the programs and select the ones to view in order for them to be manageable, because really detailed program names are really difficult to pull any trends from because there may be so few graduates in each program. So we needed to group them at a bit of a higher level. So here's kind of a slide just to kind of let you know kind of which programs are included in this and which programs are not included. Part of this is we wanted to follow kind of the way that the ATE program thinks about technician programs. And so when you apply for an ATE grant, you're not eligible if it's a healthcare technician program, for example. So we exclude any healthcare technician programs. And then we're looking specifically for 6-digit programs, which we're going to roll up to the 4-digit level for program names that have the word technician in them, and that are in, as well as are in some SIP families that are very technician focused, such as you can see, engineering related technologies and technicians, science technologies and technicians, mechanic and repair technologies technicians, and then precision metalworking. So we kind of take all of the 6-digit level SIP codes and then roll them up to the 4-digit level. So there may be multiple what you might think of as a lower level program rolled up to kind of a mid-level program level at the 4-digit level, so that we can kind of have enough data to show results. We did exclude some SIP families because they were more focused on maybe academic preparation or did not seem to be as relevant to the typical ATE grant. Like when we look through the ATE grants, there's not a lot in these areas of like library science, construction and trades, personal and culinary services as well. And then we also excluded some others that seemed to be outside of the ATE realm. So that's kind of what we included and sort of the rationale for that. So the functionality, you'll see the views in a second when I display the application, but we have a national view. It's also set it up so you can search within a state by program, so that way you can compare multiple programs within a state, or you can look at one program across many states. And then the fourth tab has an occupational view, which I don't have listed here. I can probably just go like this and allow the application to load just as a demonstration. When you get to the application, no data loads initially because we want you to make a selection at first, and we want to just so, for example, on this. Your first choice is to choose a program name. So we're at the national level. You can see view the national trends by program, and we kind of got a little call out here that allows you to compare the number of completers nationally. And then you also have the option of selecting degree levels. And so we're just going to leave them all selected, but you can select degree levels. And this is all based on the data collected from the Integrated Post-Secondary Education Data System, the IPEDS data system. So that's all the data that we've combined and collected from all the colleges that report to that system, and we've aggregated it here by program and year and degree type, so that you can kind of see differences by degree type as well. But for now, we'll just kind of put them all together. We'll just look at computer engineering, and then no data displays until you click the show data, and then you get a little that displayed faster than I was expecting it to, which is good. And you can kind of see the pattern of the number of students who graduating in computer engineering in all these degree categories, earning computer engineering technician degrees. And you kind of see something that you might expect, which is that, wow, there's a really big peak around the time of the .com bust, right? And then we see a fall off after then, which is kind of an interesting, which suggests something possibly interesting about the focus of community colleges in terms of what fields they're trying to train their students in. But there was a lot of training, obviously, right around the .com bust, but now maybe they're thinking there's not as much demand possibly for associate's degree or technician computer engineers. So maybe they've turned their training efforts towards other fields, possibly at a higher degree level, because there may not be as many job opportunities. We don't know. I think that's one of the important things about this application, is it's not really saying anything about demand. It's just saying something about the supply. We can kind of make some conjectures about what demand might be, but it's really an application about supply. We could, if we wanted to, we could, let's see, if we wanted to just look at associate's degree for example, we could see kind of how that has done. And it looks pretty similar to the trend we saw before. A little later peak though, in 2003, I guess, was the highest year as opposed to 2000 and the other data. And then the name of the program shows over here. And then if we wanted to compare, for example, to I don't know, to another program, we click. And so I clicked that program, but you'll notice that nothing happened because I didn't click the show data button. And so when we click the show data button, now we have the tooltip that popped up before, but it also allows you now to see the comparison of the two programs and how they're kind of trending in terms of the supply of graduates being produced at the national level over time. So then at the state level, we can just basically do the application there is really the exact same thing. As it's basically that first page that you saw, but just at the state level. So again, we can select more, one or more programs. I guess I can select something different maybe. And there's some functionality here. So if you wanted to like find something, you can just type in, and that'll give you the opportunity to search for it rather than having to go through this whole scroll down list, which can make things a little more efficient. So kind of really see a lot of growth in the number in California of a lot of people being trained in this field, precision metalworking. We can see, maybe there are some, are there, diverging trends in terms of like the numbers of graduates being produced in different fields. I mean, maybe it allows us to compare to see, and this is kind of an interesting when we see precision metalworking, way more graduates in California, and then it's kind of the number of graduates in electrical engineering has kind of fallen off the chart, and electrical engineering technician programs, down from the thousands to 144 by 2019. Again, it just allows you to kind of see these trends over time, and then to compare programs. And then if you were interested in, we could switch to the, compare one program across states. So that here we could select a couple of states and just compare an individual program and see how things changed
Do that one.
over time. Marilyn, did you want to?
Oh, I said, I was going to say do the electromechanical. So perfect.
Oh, okay. Oh, good. Okay. I thought that's the one that we had discussed.
Yeah.
And so we see differing trends in California versus Florida in terms of the number of technicians produced in electromechanical instrumentation, for example. Marilyn, did you have any thoughts on that specifically about the electromechanical?
Well, I did in comparison to the electrical engineering, not necessarily this one, but the trend. So if we wanted to go back to just the electrical engineering technology and electromechanical.
Okay.
That's for California.
And so I'll actually just take off precision metalworking because we don't really need it.
Okay, great. So one of the trends that we saw in Florida, so this is observation over time and knowing the programs that exist in the state, is that those electrical and electronic engineering technician programs started going away, or they started being transformed into electromechanical as the industry changed and electronics became more plug and play. And not so much, board building and wiring. They would buy the whole motherboard or the whole electronic board and plug it in. So some of those skills weren't needed so much, and those technicians weren't needed. But some of the fundamental skills were still needed, and many of those programs started to shift to electromechanical. Looking towards automation or mechatronics, in today's more recently into mechatronics programs where those electromechanical got married with communication skills. So you see a little bit of that starting to happen right about the right time at the electronics falling off almost a decade ago now, and these other programs starting to build up, and sometimes they were just replaced, sometimes they were morphed into different programs. So certainly doesn't tell you anything about the why, it just tells you what did happen.
Figured I could show Florida since you were talking specifically about that.
And we saw that happen in Florida, where we changed to advanced manufacturing, and a lot of the electronics programs kind of fell off.
Yeah, you see it with the electrical engineering being, I don't know, around 1,500 here in the late 90s, down to basically a third of that at the end of the period, with still a small number trained, but triple what it was at the beginning here.
So anyway, of course, that reflects industry needs at the technician training level for sure, and what industry was here, and if those electronic industries, picked up and moved, or closed down because their core skills weren't needed. Some of those things happened. In the process of that, we don't. Again, like you said, we don't know the why. We just have this is what happened with the technician production. So.
And I'll show just, I'll do one bad data visualization, but that I think actually will give us some insight into maybe as a possible use of this tool. I'm actually going to select all the states and then show a bunch of data, which is going to be pretty awful, but I think it can be interesting, because if we're curious, like where are we seeing like large numbers, like where are we seeing the greatest numbers of, say, precision metal workers? So we can kind of look and we can say, okay, we're seeing them in Texas, California, Georgia. So Texas, California, huge population. So it kind of, may not mean a whole lot, but Georgia, Kentucky, Louisiana. So I'll just kind of like deselect these, and Georgia, Kentucky, Louisiana, and then Texas, and then rerun that just to get it, because it just can kind of give you a sense of like, okay, where are colleges training large numbers, and where do we see a lot of growth in the training of students in precision metalworking. And it's kind of interesting because all of these schools started with similar numbers of all of these states started with similar numbers of people trained in these areas, but then you see really pretty significant growth in all of them, but really substantial growth in California. Although it's a large population, it started below Texas started below California and Louisiana. So I don't know. And I think this is a useful tool that maybe states could use, and colleges could use to think about, okay, what's like the supply of technicians being trained in areas that I'm interested in possibly offering a program in, just to do that sort of cross-state comparison. Just wanted to illustrate that. I'll do a demo of the occupational tab here. And so what happens here is like you select a state. I just selected Alabama and I picked civil engineering. Again, you can select the degree levels. And then what happens is the occupations, there's not necessarily a lot of occupations that are associated with each one of the programs, but the occupations that are associated with the programs will automatically pop up. And then the most interesting thing about this data visualization is that it will show the occupational data as well as the training data. And the occupational data is interesting because it shows kind of the number that are employed in the occupation on the tooltip, as well as the median annual earnings over time. So you can kind of see how that evolves over time. The comparison to the number trained obviously is something that isn't super informative, because given how many people work in an occupation, for all of these training programs, you're going to see a flat line, right? Because there's what might be a lot of variation over time, from 100 down to 22, or from 50 to 22 is dwarfed by what's on the shown in the employment part of it. But we think this is useful just because it gives you a chance to kind of see what is demand like, what are the salaries like, what's the number employed like in occupations that are related to some of these educational programs. So I think I could keep sharing my screen, but I figure I might turn it over to Marilyn. I'll also just point out that there's a user guide as well that you can consult for data sources and some more detail. We have down here for each of the 4-digit programs that you can select. We show the all of the names of the 6-digit zip codes that are associated with the 4-digit programs that you can select. So if you're interested in understanding what programs kind of go into the counts that you're seeing on these screens, that's the place to look. So I'll turn it over to Marilyn now.
So these would be programs that were in place or are in place today that would be captured by this particular analysis that we're going to look at right now. The
Yes.
Electrical and electronics, engineering technologies, that's kind of a cover-all. Some separate ones for integrated circuit design, laser and optics, telecommunications technologies. So when he pointed out at the beginning this roll-up of zip codes, this is one a good example of what we would do. So now let's go back and look at the data again for this and the electromechanical.
Okay, should we at the national level, or?
Yeah, let's do the national level. Right, so now you see this kind of big change in electrical and growing electromechanical with the data that he suggested you could get in the call outs there. You can see the difference in those two trends, and the electronics just kind of dying off slowly, even across the country. So now I'd like to go back to the the user guide and look at the zip codes for the electromechanical. Quickly, if we can do that. So people could find out, schools could find, more detail about their program, where they fit in these higher level codes by going to this tab. So this would be, for me, it would be important because we have programs in all of these areas, and we want to know what's included. So for example, in Florida, we have some that are called automation, some that are called, that are biomedical that I might not include in an electromechanical group just by name. So it's important, I think, for the colleges that would want to use this tool for any analysis to go to this particular page and check where their program really fits at the more discrete level there. So I wanted to just point that example out. And so not so much on the data this time, but more on where to find the data you might want. Because it won't, the tool won't search on the 1 through 6 specific. They've been added together in the search, so the visualization. So that's all I had, and thanks, Bill. Hopefully we'll have time to talk with a couple of folks in the audience. And thanks everyone for joining us, and have a great rest of your ATE PI conference.